today we're going to be looking at particle diagrams in class. And basically, what a particle diagram is you're looking at a picture of the atom or atoms that make up your element, compounds, or your mixtures. Your particle diagrams are also like microscopic, if we could break down and see the individual elements or atoms. So let's first look at elements, our first type of pure substance. Remember, elements are found on the periodic table and they can't be broken down into simpler substances. We have two types of elements. We have monoatomic and diatomic. Most of the elements that make up your periodic table are monoatomic, which means in nature you will just find a single element like iron, silver, gold. Those are all example of monatomic. So if we look at the particle diagram of a monatomic element, it's a single circle. And this one is a single blue, it could be a single red, or a different monoatomic element would be shaded in blue. Okay, so let's just say this one is iron and this one's representing silver. Okay. Diatomic elements are where you have two of the same elements that are chemically bonded together, and they occur that way in nature, naturally. So, oxygen is a great example of a diatomic element. Oxygen always have two oxygen atoms bonded together. It's always O2. The other that make up that seven are hydrogen, nitrogen, fluorine, chlorine, bromine, iodine. You don't have to worry about knowing those elements for right now. We will get to them later on, but you need to be able to realize that this is both a particle diagram for diatomic elements because this is showing two of the same type of atom. And then this is another example of diatomic that are shaded in. So we could say this one is representing oxygen and this one's representing hydrogen because it's H2 also. Compounds are the other pure substance of matter. Remember, compounds are two or more elements that are chemically bonded together. So if you want to break them back down into their elemental form, you have to go through a chemical process. So I have four examples of different types of compounds. Our first example here of the compound is showing a binary compound. We have two different atoms or two different elements that make up this compound. The other three examples here are also binary compounds, but it's a ratio of 2 to 1. Okay, so this could represent, say, this is oxygen here, and these would be two hydrogen atoms right here. Okay, because you have two hydrogen, one oxygen. So again, these are two of the same atoms. This one right here that's open and outlined in blue is a different element or atom. And then we have two that are solid, and then we have the solid blue that's a different element. So again, examples 2, 3, and 4 are also compounds, but instead of having a 1-to-1 ratio like example 1, it's 2-to-1, 2-to-1, 2-to-1. When we look at our mixtures, remember mixtures can also be referred to as solutions, and they have a regular pattern, okay? And mixtures can be made up of elements. They can be made up of two different compounds. They can be made up of elements and compounds. So I have four different pictures here showing different types of homogeneous mixtures. So they're going to have the same ratio or the same number when you look at it, because every sample that you take will be the same throughout. So our first example is a mixture of diatomics. So we have two diatomics here, and then this is our second diatomic that we have two of them. So we have the same number of two different compounds, so it's a homogeneous mixture. If we look at this mixture of elements, this is a mixture of monoatomic elements. So 1, 2, 3 of one type of element or atom. And then here are your second element that make up that compound, 1, 2, and 3. And we know that they're different, but they're the same. So we could say these are 3 iron and these are 3 silver. If we look at the diatomic, we could say these are 2 oxygen and these are 2 hydrogen. So it's a mixture of hydrogen, diatomic hydrogen, and diatomic oxygen here. And this is a mixture of 3 silver and 3 iron. We look at this example down here, and it's a mixture of diatomic and monoatomic. So we have 2 monoatomic elements and 2 diatomic elements, but we have the same number, so it's the same throughout. Homogeneous means to be the same. We can also have a mixture of compounds. Okay, so we have this is compound 1, compound 2 of the same type of compound. So we could say this is water, and we could say this is another type of compound right here. Okay, and it's again 2 and 2 of the same. Heterogeneous mixture means that it's different. It's not going to have the same number, okay, not a regular pattern. And remember, heterogeneous means that you're going to see different parts, okay? So like if you look at an M&M cookie, okay, or a chocolate chip cookie, you can see the different parts of the cookie. Well, if you look at the particle diagrams of a heterogeneous mixture, you're going to see there's no regular repeating pattern. They're different. So if we look at this one here, this is a mixture of diatomics. We have 1 diatomic and then 2 of the same diatomic. So we have, it's not the same, it's a different pattern. Here we have a mixture of monoatomic elements. Again, we have 2 of one type of element or atom and 3 of a different one. So it's not the same pattern. Here we have a mixture of elements and compounds. So we have a monoatomic, we have a diatomic, and we have a compound, and it's not the same number. It's all different. Okay. And then our last one here is a mixture of compounds. So we actually have 2 compounds, and then we have 1 different compound. So hopefully this has helped you with understanding how to read particle diagrams, and you will practice identifying and the different particle diagrams next.